Thank you. Welcome to our talk. So this is Alexandre de Oliveira, and I'm Laurent Guigonis. And we are from P1 Security presenting about the mapping of SS7. So I guess most of you have seen the talk from Tobias earlier and from SRL Karsten. So this project is more going massive, and with the different vulnerabilities that were presented in the past, including the vulnerabilities presented today by Karsten and Tobias, getting a view of these vulnerabilities worldwide on all the countries and how to make a map from this to see what's the exposure worldwide on these vulnerabilities. So this is a P1 Security research project. And so, as you saw the talk maybe earlier, just to get a view, who knows how mobile operators worldwide are interconnected? Who has an idea? Please raise your hands. Okay, not much, maybe 5%. Okay, so basically these are two operators and two mobile operators in the world. They are interconnected together by providers called SCCP providers, and that's how you are going to be able to make calls between countries. It's because they are interconnected. And so this was supposed for a long time to be a walled garden because it's a closed network. So mobile operators are interconnected via a closed network. But more and more, as we saw many times in previous presentation, it's not a walled garden anymore because more and more operators, more and more third parties are connected to the SCCP providers. And also some parties are connected directly to one operator, for example, governments for legal interception. Operators are also, of course, connected to internet, to GRX providers, various internet services provided by other companies, and that gives exposure on their network. So our goal here is to make a map of this whole internal private network. Like you have had a mapping on internet, here it's a mapping on the SS7 network. So in order to do that, we performed we created partnership with operators in order for them to help us making this. So we do it by having a probe scan inside the network of one partner operator. And then we send call flows towards other operators. And we do that from multiple operators. And so we get a view of the network. What's important to understand here is that our SS7map scan probe is inside the range of the operator, but is not considered as trusted. It's not in the roaming agreements list. So basically, it should not get answers because it's not a trusted node.
So what we wanted to show, it's since the attack surface of operators, they are increasing a lot of third parties are interconnected on the operators. We saw that the time to compromise for an operator during our mission, it's like we saw less than 1 hour time to compromise from internet to the IP core, which is the IP core is supporting the whole telecom network. So if you compromise things like IP core or the PS core in less than 1 hour, you could get to the core network directly right after. So the goal is really to show you that compromising SS7 networks, even if you don't have access and if you don't have a collaboration with an operator to get an SS7 access, for attackers, it's not so hard to get one maliciously. So we build a compromise chain to show you first how attackers could use existing SS7 stacks on existing network elements to be able to send messages. And this could come from internal, from OAM compromise, from governments that can use also, that are interconnected with network elements for LI purposes. And as Laurent said, operators, when they want to interconnect with each other, they have roaming agreements, and these roaming agreements, they define every network element that they want to be in this roaming agreement with a GSMA RAX IR21 files, which contain all the network elements global title, which is the IP of network elements. So it will be a phone number, international phone number, that you will be able to access network elements through this global title. But what is really interesting is this file, we get it from the internet. So this should be completely private, but on the internet you can find IR21 files publicly available. So you will find internal GTs of operators directly accessible from the internet. So this is one of our resources. And you see also vendors, you see the network equipment location directly. So it's already useful for us. But you see also the SGSN, which is on the packet part of the core network. You see the public IPs of the SGSN. So it's not really public IP, it's in ranges of public IPs, but they are private for GRX network. And this means that you could take these IPs and you could check on the internet if they are not reachable, because normally they should not be reachable because it's inside a private network. But if it's something misconfigured, you could access them. And on Shodan, you can find a lot of GGSNs that should not be accessible on the internet directly. And this was only a query or GGSN on Shodan. So now let's take a look on what we can do and what it's inside an operator that we can do. So the first thing is taking a look to how it's address an operator. So how is address an operator? Usually you will have, it will define a prefix. So for example, on this operator, it will define a range only for network elements. Usually it's how it's done because they wanted to have all their network elements into only one range. But maybe since they are adding more and more network elements, they will add other ranges. So the ranges are so large that if we are not doing this smart approach of trying to understand how it's built the addressing space of an operator, you will not be able to find this network elements.
So just to give a little view on this, the numbers here are global titles. That's how network elements on the SS7 are addressed. So the address space is much larger than IPv4, for example. So you can't just scan sequentially. You have to find tricks like on IPv6. So basically, that's why we are going to explain the different address spaces.
And when you take a look to network elements in this address space, you will have the HLR, which is the main database, MSCVLR handling the switching where users are attached, IN, so intelligent network for postpaid, prepaid options, testbed, again MSCVLR, and all of these network elements, usually they are well separated and they are packed. So if you find one, if you start to go incremental, you will find others, okay? But did you see any problem on this slide? I see one, I see the testbed, which is directly on the production ranges of the operator. On this, it's often the case, because they wanted to keep always all the network elements inside the same range. So they put also the testbed into the GT live ranges. So, but the testbed, usually it's accessible for testing, it's accessible for developing new features, for new people inside the company, so it's way more accessible than the live network. So the thing is, if you are able to get into the testbed, you will be, as the live network, able also to send SS7 messages. So it could be one way.
So yeah, the testbed can be an entry point. And what's funny that sometimes the testbed, it's the reverse. It's more secure than production. We've seen that also. So it's full of oddities, the SS7 network. It's really strange. And sometimes it's more secure because in production, they take the testbed, they validate, and then they need it to be more maintainable quickly because they want it to work. So they remove some security features. So it's really variable. It's special.
And if you take a look to the addressing evolution, so at the beginning of the networks, they had like small ranges, so small numbers. And they increase the length of the digits. So every time they increase the length of the digits, sometimes you will find all network elements in small ranges. Even if subscribers they have been merged into new ranges, the network elements sometimes they are in smaller global titles, so smaller prefixes for all technologies. So this one is how the Indian network is built. So we remark that the Indian network was built in circles. That means that every region of India has its own SS7 network, and they were all interconnected each other. So it's a good point to know because you will know that all the network elements are not sequentially in only one sequence of GTs, but there will be one sequence for every region. So you will try to find this sequence for all the regions of India. So it's really interesting to try to understand how the network is built for the country to be able to understand how. Yeah. So another thing is when someone buys another telecom operator buys another one, it will add more network elements into his pool of network elements. So you will think that it's always a good thing to take a look to all. For example, for the major ones, they will have operators in all the European countries, for example. So it's interesting to take a look to, because sometimes, for example, one country will be more vulnerable than another, but since it's a huge company, they will be directly interconnected. So if you are into this, into the country less secure, but you have a direct interconnection to a more secure country, it's not secure anymore. Telecom regulators, it's because, for example, for France, we had 336 for mobiles, and now we have 337. But since 337 is a new one, don't even take a look because there will not be any network element inside these ranges. Okay, it's new ranges, so no network elements. Something funny on this one, during our scans, we remarked that when we were trying when we were sending SS7 messages to Costa Rica subscribers, HLR from Spain was responding to us. So this means that the operator from Costa Rica, he had a part of his network still in Costa Rica, but the HLR was in Spain. So maybe for custom optimization, to get all the subscribers into only one HLR, so yeah. So now what we want to do is send MSUs, because we want to be able to send map messages. And the first thing that we want is to try to scan the network. So we can do it in two phases. The first one, we will try to get directly the GT of the HLR. And to get the GT of the HLR, you have a lot of messages that as input, you have only to put to give a subscriber number. Okay, a subscriber MSISDN. So this messages, you give them a subscriber MSISDN, you send them to the SS7 network, and in the routing of the SS7 network, the SS7 router will know that, okay, it's one of my subscribers, so I give it to the HLR. So the HLR will respond to us. Even if it's an abort, it will respond to us. So it's still interesting to know. And the second case, it's to use, as we saw before, the IR21, the ITU, but even your SMSC public GT. This one, you have it on your SIM card, right? You will find them on internet, the public SMSCs. And usually, since all the network elements are close together, if you take the GT of the SMSC, maybe by incrementing, you will find the other ones. It will not be so complicated. So maybe not, maybe yes, so it's already a good start. Because it's your first GT that you will have. So this one, it's a TCAP scan. So we scan incrementally the GTs for the SSN, which is like the TCP port for HLR. And when we got an abort, you have two cases. Or you think that, okay, the HLR responded to me. Or the second one is, okay, the SS7 firewall blocked me and he sent me an abort. So you have two cases, but at least, usually when it's a firewall, it will put as source your own GT. So, or the MSISDN that you inserted as destination. So you will know that it's the firewall. If you have a different GT which is responding to you, you have more chance that it will be a real network element, so the HLR.
So as we see, all this network is full of oddities. One network can behave in a way, and you will scan another one. It will behave completely differently. Maybe the HLR will not be responding, and it will be some firewall in the middle that will not even put its GT. So from all of these behaviors, we built a scan engine, and taking some public data sources as input, as well as private data sources, in order to build kind of a mobile operator database. And then the goal was to check the reality of all this data with the network. So we take data from internet, from SPCs, ISPC, from ATU, from some IR21 also can be good start. Also from attack reports from operators in order to put some risk already at the beginning inside our ratings. All this we give it to our scan engine that will run send the MSUs on the SS7 network, and from this we are going to generate mainly these 4 items. So the SS7map website that we are going to release now. Ratings per country, and then some part that are private operator security details. So we plan to release this publicly in the future. So maybe 6 months, that's what's planned. And also a threat intelligence on the SS7 network.
Because we want to give operator a chance to first contact us, and we will send them directly, privately, the data of their operator. So we don't want to give it directly publicly, but first give a chance to operators to ask us, and we will send them directly this data.
So what will be released today is only the country level of security from the SS7 roaming infrastructure. So in order to make this map, we need to send a lot of data, and so in order to then start to visualize it, see what message work, what doesn't, we generate some graph. We try to understand the network. So for example, here we send different type of messages. That's what you see at the bottom. So known ones, SRI SM, SRI, also interrogate SS, PSI that are less common. And we see how the network behaves. So here we started to list different kind of errors, but there are many kind of errors, and it's those oddities that will actually give us more insight on how to map the network. So on this one, what we see mainly is that many countries, many operators are answering actually to the requests that we send them. So it's there are 4 lines each time. The first one is positive answers, then you have no answer, and then you have 2 type of errors, 2 different type of errors. This is for ATI, this is for SRI SM, SRI and PSI. So you see that on this line, one dot is drawn every time it matches. It means if I have one dot here, it means that an SRI had a positive answer. So very often the bars of positive answer are quite dense, and even on SRI and ATI messages that were discussed by Tobias and Karsten earlier, you see that there are very much answers, even if they should not be allowed from INAT 0. That is the INAT 0 mean international, basically, for an operator. And at the beginning, we should not even have any answer for any of these messages because the GT from where we scan was not in the roaming listings. So one slide on some more oddities of SS7. This is the delay depending on the message that we send. Those are the different colors and the type of result that we get. So you see that, for example, sometimes we get answers 10 minutes after we send the message. So on IP, you would not even think about that. How can a machine answer 10 minutes after? We see some of this. Sometimes, so this was, okay, a special case. But you see that even if majority of messages are very fast to be answered, there is still a big part here that take between 10 seconds and 1 minute to get answers, and this depends on the countries. So this is also the delay time way to fingerprint the network and try to understand it and to map it. To see the different behavior and say, okay, this country is behaving like another one. Why? Maybe they share some specificities. Maybe it's a vendor related. Maybe it's something else. Maybe there's a problem. So from all this data, then we built algorithm in order to extract ratings and then ranking for countries and then a map. So basically, we split our ratings in two main parts. So network exposure, which is operator related. It's about the exposure of the network itself, and also privacy leaks. Privacy leaks, it's related to the customer, meaning all of us. So it means if does my country or my operator really protecting my private data? Private data can mean location. It can mean also authentication vectors, because if they can be obtained by someone else, then this someone else can impersonate the network, for example, and then intercept your calls and decrypt them, like Tobias, like Karsten presented. And so these ratings, okay, they are a bit complicated. We will post, we will have blog posts for those that are interested, linked to the website with explanations deeper on this.
So okay, now let's take a look to the website. So this is the SS7map website, which will be released soon. So what you have a global risk, which is a calculation between the privacy leak and the next network exposure. So first, I will show you on the privacy leak. So when we take a look to the privacy leak tab, what we see is, okay, there is some countries in blank. This means that we don't have yet data, and since it's an in progress project, we will improve it and we will add more and more data during after the talk. So in the next months. So for example, if we take a look to the United States, because they have been like in the center of all the discussions about intercepting calls and all this stuff, we are giving a page. So this one will be directly accessible and will be directly public because it's for the country and not for specific operators. So we will give on the operators that we have the data that we have been able to score. So for example, for the privacy, what we are testing is, for example, if there is some messages disclosing the precise location of a user. So the first one will be disclosing MSCs which are like less accurate. And the second one, which is this one, will be disclosing cell IDs, GPRS coordinates, so PSI, ATI, PSL messages. And so you have also all the other messages. So for example, the authentication keys for SAI, you have prepaid, postpaid subscriber status for interrogate SS, and other will be added. So for example, the routing, the home routing bypass will be added soon because we are still processing a lot of data that we have. And the goal really is to give an overview of the vulnerabilities that you will be able to find in the operator of this country, and to really try to get a good vision of the security of the country. So yeah, United States, they are attacking everyone, but still not securing so much the network. So how we did it for privacy, so for the privacy leak part, first we took messages such as SRI for LCS, SRI, SRISM, ATI, and SendIMZ. This one they only took as input an MSISDN, which is a subscriber number. So what we did, we did web scraping to get a lot of MSISDNs. So I don't remember the number of MSISDNs that we got, but thousands of them.
Yeah, thousands.
Yeah, exactly. So the number, so we get all these MSISDNs, and first we sent the map MSUs for all these messages. The only one that need another entry, it's the SRI LCS, which needs the GMLC GT. This one should be private, but sometimes you are able to get it because you can or sometimes it's not filtered properly, so they will not filter on the GMLC GT. So we saw that on some countries that are like giving directly the IMSI on the MSC via the SRI LCS, but okay. So these messages, what they will give in output will be the IMSI, the MSC VLR and MSC GT, and the HLR fingerprint. We have been able to fingerprint HLRs through this. By really analyzing a lot of data, we have been able to directly fingerprint HLRs to be able to say, okay, this HLR is from Ericsson, ASN, or this brand. It's like we have been able to identify directly the brand of the HLR. Not exactly the version, but at least the brand remotely. So we get the IMSI on the MSC VLR where the subscriber is attached. So now we can send another type of messages, which are the interrogate SS, the send authentication info for the authentication of the subscriber. So this will give you the cryptographic key of the subscriber. The PSL and the PSI. So the PSL will give you directly the GPRS coordinate of this subscriber, and the PSI will give you as the ATI the cell ID. But if you have the cell ID, you will be able to get the GPS coordinate also. So this is really interesting.
And this is basically a progress map. How can you, from only few informations, get to the cell ID to give a picture of what's actually inside the scan engine that we have a part of it?
So yeah, only from an MSISDN getting all this information. So this is a little recap of all the messages that we sent on the network. And as we can see, like ATI, PSI, and PSL are have the more impact because they are leaking directly the location, the precise location of subscribers. So this is really interesting for us. And also SRI, sometimes you have also the cell ID, but it's not so often. So, and we took an example. So for map API, for example, if we take a look to the specification, so 3GPP specification, we see that only the location management function should be able to send map APIs to the HLR. And this is a local node, okay? So only the local node, the low management function local node should be able to send map APIs to the HLR. So this is for 2G and 3G usage, but for 4G, they added something else. So the HSS, which is replacing the HLR for 4G, so the database for 4G, can also send map APIs to the HLR. So always internal. And this API, as we say, is giving VLR, MSC GT, the cell ID, the age of the location, and the subscriber state. And what we saw by analyzing all the data that we got is that on the map API, only 29% of the networks, of the requests that we sent were responding correctly to the map API with the cell ID, with a real cell ID. But if we take a look to map PSI, which now it's not so well known than map API, because Carsten and Tobias, they speak about API, which is now well known, and all the German MNOs are blocking it. But if you take a look to PSI, like you have 82% of the requests that we sent, which were responded correctly with a cell ID into the PSI. So this means that, okay, my API is not working anymore, let's go to PSI. And it's always like that. You will always find new vulnerabilities on the SS7 network to get information from it. So really our goal was to get an overview, statistics, because vulnerabilities, we have been exposed them for years, and we wanted to really get an overview, a worldwide overview, to see that, okay, map API, it's responding, but not so much, but okay, let's use map PSI, it will be better.
By the way, this one, it shows some mentality of the operators is that map API, it has been discussed much earlier. So now they are blocking it. So like, okay, this message is bad, we just block it. And sadly, many didn't think wider and think, okay, maybe we should take this seriously and see what are the impact of all the messages and work together with people doing research in the domain in order to really have a clean filtering on the perimeter boundaries. So the evolution is that maybe 10 years ago, ATI was answering everywhere. Now it's much reduced, but PSI that has been less discussed. Operators are still widely vulnerable, and so basically this is 82% of the operators worldwide are answering to PSI, so it's pretty bad.
So yeah, one of the recommendations that we give to operators, it's, okay, ATI, you should block it from in at 0, that it's pretty clear now. But you have two types of defense. You have the first step of defense, which will be blocking it on your router. But the second one will be defense in depth by blocking it directly on your HLR. Because, for example, maybe you will deploy another STP and you will forget to put these rules, or maybe the routing will come from a national interconnection and you don't have this filtering rule through it. So always the best, not only on the edge of the network to put your filtering, but also to put filtering in depth directly on your HLR. Because you can bypass filtering at the edges if it's not well done. But filtering in depth, it will be harder to do it. And one really interesting thing to do, it's since we have IDSs also on telecom operators, we are monitoring map APIs coming from the international. And this, it's really interesting because map APIs, they should never come from international. So if you see them, it's like, okay, this GT, maybe it's compromised. Maybe this GT, it's coming from a firm that want to locate users. So monitoring map APIs, really good. So now let's take a look to the network exposure part. So when we take a look to the privacy leak part, okay, it's look pretty yellow, but when we go to network exposure part, it's a bit more complicated for operators. And why? For example, if we take again United States, why it's worse than on network exposure than on privacy leaks? It's because at the beginning, a lot of small operators build their network, okay? But after time, one operator bought another, and they grow up like that. But they build the network by buying other operator in other region of United States. But it's harder to try to build security when you are buying new operators than when you are building your own network directly. So it's one reason why United States, if you take a look to the network exposure level, you will have a larger attack surface than on the privacy leak level. So this, it's like you will be able to directly target network elements on the SS7 network of United States, for example.
So the idea of this data, it's for both operators to see, okay, what's at first countries to see what's the level of security, and also for users to see for countries and operators. Okay, actually, my country is not, or my operator is not taking seriously the notifications from the security community saying there are problems on SS7. You should take this seriously because it has impacts on our privacy. People can track us, and so it's also in order to push this. Of course, some operators they have done a great job at filtering these messages, and they have great internal teams that understand really all these problems. But sadly, they are still majority, so that's why we are still here and doing this scan to bring visibility on this domain. Because on internet, when you want to see, for example, you have an IP, you want to see for example, you had an attack from an IP. And you want to know where is it located. You can run a whois. You have many bots on the net that are scanning and that are reporting, okay, this IP, it's part of this range, it has been signaled for these problems and these problems. On SS7, you don't have that. So what we want is to make the cartography of the SS7 network in order to bring visibility to operators to be able to react actually when there is a problem. So that's another goal of this project.
So now on network exposure, we have less messages, but we are still like a large part of map messages. So SRI for LCS, SRI for SM, ATI, these 4 messages, they will give us the MSC and VLR or VLR GT. So interesting to know because you will have already real GTs are inside the ranges of the production network. You have map send authentication info. Why map send authentication info? Because it's one of the with the most like you get one of the map messages where you get the most most responsive. So you are almost sure that when you send a map SAI, you will get the HLR GT back. Okay? And the last one, it's the TCAP scan. So this one, it's we developed it ourselves. It's sending specifically crafted TCAP messages to be able to scan GTs in large ranges by incrementing on the GTs, but also on the SSNs. Because SSNs, they are like TCP ports. And for example, for the HLR, the SSN, it's the number 6. For VLR and MSC, 7 and 8. So every network element will have its own SSN. So if you want to discover all the SS7 network, you will have to start doing things like that. And you will have 2 responses on the TCAP scan or a TCAP abort or nothing. TCAP abort will mean usually that there is something behind this GT. So a little recap also on the network exposure, where we got the most responses, the TCAP scanning, because it's like we can go for large ranges, really useful. And now the RICO part.
Sorry. So as we discussed, there has been I mean, SS7 is being looked at for many years, since 2007, one of the first public presentation, up to now, 2014. There has been more and more presentation, because this year it's 5 presentation on the subject, and it's a 20 years old technology. So actually the vision on this network is coming now, but it's really an old network.
And what is happening, for example, with SCADA before? It will be for sure happening with telecom, because it's an obscure network, but more and more people are discovering it. So
we make a quick recap of the last presentation. And from all these scans on the net, we were able to gather statistics for worldwide exposure of operators, to be able to see, for example, the location of a subscriber worldwide, how many % of operators are vulnerable, and for the call interception, also how many operators are vulnerable, to see how much work needs to be done still. And thanks to all this scan, we are able to see this and to see the evolution. So from now on, we have a base of results, and with running the scan continuously, we'll be able to see what's the evolution of all the roaming infrastructure ecosystem.
Yeah, and this is really huge, because you see that 72% of operators that we scan, they were vulnerable to a precise location, so it's getting the cell ID or getting the GPRS coordinates of a subscriber. So this means that, okay, there is a lot of companies doing tracking, but if you get any SS7 access, even with a non-trusted GT, not in IR21 ranges, you will be able also to do precise location of subscriber on 72% of operators. Okay, and for the call interception, like 66% of the operators, it's huge, because it means that from the international, you will be able to intercept the calls of anyone.
So from our point of view, it's good, because we see that actually security is bad, but from the perspective of the operator, it's good also, because it can see its exposure change in the time, and see publicly that, okay, people see that actually things are moving on and things are changing for our security, and that so the changes don't go unnoticed. So this project is still in a research phase. So we release a website with only countries. There are things that we are going to improve, like ratings, and also mapping more kind of vulnerabilities. We saw that on the map some are to be announced, for example, and also giving a vision on the evolution of the security of these networks. And of course, also what will be very interesting is to develop partnership with the operators in order to get more different vision on the network, because as we saw, the network is very diverse. There are many oddities. So the more point of views we have on the network, the more vision and the more quality result we'll be able to give back then to operators in order to better describe this network, basically, because now it's very obscure.
Yeah, for the moment we have like 3 interconnections through different operators, so it's really interesting already for us to get the differences between the 3 interconnections. But with more interconnections, we will get more results, since we maybe don't get all the responses because we don't have all the roaming agreements with the good operators. So yeah, we are open to partnership with new operators.
And then, of course, so we talked about SS7. Now operators are interconnecting for LTE using diameter. So the next step is, of course, a diameter map that will be mapping the roaming infrastructure, but not the SS7 one, but the LTE one.
And LTE, it's a bit better than SS7, but still there is a lot of vulnerabilities that have been put from SS7 to LTE, and this work it's still in progress for us, and we are doing a lot of work on LTE. So we will announce during this year new things on LTE.
Yeah, because one thing that we see that all the people that learned from all this roaming kind of culture in the operators, sometimes they are not put in the new roaming teams that are handling the operational side of the LTE roaming. So that it's more IP guys that are put with diameter protocols. Okay, but the guys that learned a lot from SS7 roaming, they are not transferring their knowledge to the diameter, to the guys that will handle diameter then. And all the logical aspects of SS7 are kind of transferred to diameter. So the attacks logically many attacks are logically the same. So yeah, that's one bad point already that we saw. But it's another subject.
Okay, thank you for your attention.
So SS7map is online right now at this URL, and if you have questions, we have a mailing list also available.
T'as viré le hashtag access?
Ouais.
If you have any questions, please do line up at the 4 microphones that we have here. What I know for sure, we have at least one question from our Signal Angel relaying questions from IRC. Signal Angel, please.
Microphone? Yeah, okay. So we have one question/remark from the IRC right now. First, they say it's very good work. You mentioned earlier that your probe was in partnership with an operator. What are your strategies for opening new or expanding existing partnerships?
Sorry, can you repeat,
please?
If you're leaving right now, please do so quietly.
Yeah.
Thank you.
First, they said that you did really good work. And
Thanks.
then they ask, you did your probes in cooperation with some operator, and if you have any plans or strategies for getting new partnerships or extending your collaboration.
To extend our collaboration, the best way to do it, it's like operators, they want to be more secure, and what we are offering to them, it's to work with them in a real partnership to help them to get more secure, and by helping us to scan the network, we help them also by giving them the information that we get from the scan to improve their security.
For example, when they have an issue and they have one GT that they identified as a source of an attack, we can come and help and see, can we find this GT in these scans, and then we develop, we discuss with us and we react on this. And also then if they are okay to partnership with us, we go and validate all this probe that is sending messages with them, and we show how it works and how it will improve their vision on their own network and on the network worldwide.
Because usually it's already a huge step for them when we gave them a map of their own network. They're like, oh, my network looks like that. And okay, they are managing the network, but they don't even know how it looks like on a real map.
Yeah, so, because there are no tools. It's not like IP, like you can run an nmap on a network. Here, you need to have custom tools because the protocols, everything is custom. So it's really some stuff that we give, we provide to operators.
Mm-hmm. Okay, thank you for your very detailed answer.
Microphone number 4, please.
Hello. You said about the GRX network that you can find the IP ranges in the public internet, so then you can scan them and maybe find some vulnerabilities. When I worked for a telco, in our case, this range was used for the 3G customers, and the range, it was the same as for the GRX, so it was like routed differently. So even if you scan this GRX, pseudo GRX network, you are just scanning our customers and you are not getting any real vulnerability data. So just a notice. And we decided maybe it's a better idea to not to use this range for our customers. And are you providing the data from your scan for free to the telcos?
To the telcos, we are giving statistics on their own network, but not raw data. We can discuss about that with them directly to give them more details. No problem about that. But for your remark, for example, when you see the KPN talk at Hack in the Box Amsterdam this year, they disclosed a scanning of the GRX network, and they found like thousands of IP and TCP ports open, like mails, DNS servers on the IP of this GRX public, the GRX public IPs. So maybe your network you are doing it properly, but a lot of networks they are not doing it properly.
One last question: do you know about malicious GTs already, like the malicious sources of this scanning?
Yes, we had. So this is mainly from feedback from operators, because when you scan actively, you won't see GTs that are attacking because it's an active scan. So this data, it's from attack reports from operators. So this is different from SS7map.
Thank you.
And we have also an IDS in telecom running, which is giving us feedback, like for example, ATIs coming from international.
So this would be more fitted, but this is not for SS7map, the detection of GTs that are malicious.
Microphone number 2, please.
Yeah, just a short one. Do you have the German dataset with you? Could you give us a sneak preview maybe or something? But USA is quite interesting, but I'm more interested in actually a European country or something.
Of course.
Thank you.
So for Germany, for example, we got 4 operators.
So this is the coverage that we have. Sometimes we don't scan all the operators of the country. Here we have all of them.
So for the privacy part, it was pretty good, but the network exposure, there is still improvement to do. So privacy part, they are blocking a lot of messages. So ATIs, for example, as said Carsten and Tobias, but all the messages they are not blocking them. And yeah, but it's important to keep in mind that it's still an in progress project, so we will improve our scanner on all our scan engine. So the goal is to bypass all the protections also, because we learn every time how they protect the network. So we try to bypass it to get vulnerabilities on the networks. And yeah.
But so here quickly, here the number 2, for example, it means 2 different map messages are allowing an attacker to get a subscriber location. So this means that in Germany, per operators, there is a mean of 2 messages that allows someone to get a location of the subscribers of the operators. So that's not good. That's why it's in red. So we have a colors on this. So when it's red, it means pretty bad. When it's yellow, it means it's bad. But it's not. So. Of course, the ratings are relative to other operators. We could not put everyone in red when it's bad, so it's kind of adaptive, and we are waiting also for feedback. But I trust the data that you are here. We can discuss it if you have also.
Microphone number 4, please.
Hello. You talked about exposure of subscriber data, but Is there also exposure of network data? Like, could you count the number of subscribers or?
So there is exposure of network topology data.
Yes.
So when I talked about the ratings, I talked about two main categories: privacy leak level, that is here, and network exposure level, that is here. So those are the two main categories. And then you have subscores. So for network exposure level, we have the SCCP attack surface, which is basically the number of network elements that we were able to discover. And then the fact that whether we were able to fingerprint it or not. So that's the second one. And then we have a potential change of prepaid, postpaid status. That means that, and here it's quite low, so it's good. This rates the fact that someone can modify data on the infrastructure.
On the subscriber plan directly. So passing from example from prepaid to postpaid. So
this is a vulnerability for the network.
Yeah, of course, but in the protocol there aren't any extensions for how to say attached network or for to get the routing or something like that.
There are extensions for protocols, for SS7 protocols like map extensions.
Yeah.
And this data, we still do not have it processed and normalized in a way that we can display a score, because there is much steps before getting a score from the raw data of the scan. So this is coming. This is the work in progress that we are doing. But for now, that's what we can present per country.
Because we are sure of the data and we clean everything which was suspicious. So the goal was really to give a good overview and an overview which was not with good data always.
So we still are missing also some countries, for example, but this will come, and there are countries where we have less answers. So there are countries where we are more confident. This will move on, and we'll get a full map with a full view on this network. And then in 6 months, after discussions with operators, we'll be able to release a per operator rating.
Do we have any more questions? There's one on microphone number 2, please.
Suppose I have a Dutch subscription and I'm in Germany right now. How do I interpret your risks and the vulnerabilities you found? I assume that the worst of both will apply to me at the moment.
So I go back to the Germany country. So this means that
so you are a subscriber, so you take a look only on the privacy, what will affect directly the subscriber, which will be the privacy leak level mainly. And okay, you can see that locating you is possible because German operators they are not protecting, for example, for one of the map messages that is giving the location with like a street level accuracy, so the cell ID. But still, we can locate you in the region point of view because so the first line, this one, it's for a region point of view, and so still, even if they are not the worst ones, we will be able to locate you, to get your status on postpaid, prepaid, and maybe to change your subscriber plan, things like that. So this will, like, changing the subscriber plan will lead to fraud.
And actually, that's what Tobias showed on his presentation. Like he was tracking someone around the world, and the guy came to Germany, and it was his messages were working.
Yeah. I assume that also any vulnerabilities in the Dutch telco system that I'm a customer with still apply.
Yeah, that's a good question. So this, when we are speaking about Germany, this applies to customers of German operators, not to visitors.
Yes.
Visitors, it will be so when we'll have more statistics on the security of visited country, we'll show it. But for now, it's for home network. Meaning, if I'm French in a French country, then the security related to my SIM will be the one for France.
Thank you.
Any more questions? No, please give a warm round of applause to Alexandre and Laurent.
Thank you.